Hey chemistry crew, Mr. Collier here. I want to show you how to do some of the problems that you're going to be working on for page 7 and 8. If I don't do one that you wanted to see, let me know. So first I want to talk a little bit about conceptual stuff about what's going on here with Boyle's law. So with Boyle's law, we have P1 V1 equals P2 V2. So the relationships here are inversed. So if this number goes up, this number has to go down to keep them equivalent. So that's why we say inversely related. So whatever one does, the other does the opposite. So if the pressure is doubled, the volume is halved, right? And if the pressure is quartered, then it's going to do the opposite of that, which is get 4 times bigger, right? So that's the general idea. They're inversely proportional. Whatever one does, the other does the opposite. Now, when it comes to problems, you'll notice at the beginning, I gave you a little spot to write P1, V1, P2, V2. That's kind of your training wheels, and as you go on, you'll notice that disappears. So when you're reading the problem, you want to read for pressures and volumes, and here we have a volume, and here we have a pressure. So it is 36.8 mils when the pressure is 719. So my volume is 36.8 mils. My pressure is 719 millimeters of mercury. So now I need my P2 and my V2. Typically they'll have one but not the other. And as I read along, yes, indeed, the temperature remains constant. Determine the volume. So that means my V2 is going to be my unknown when the pressure is changed to 802 millimeters of mercury. Now in this problem, like many of them, my units are already converted. I've got millimeters and millimeters, so I don't need to do a conversion there. So now I just need to start plugging in my numbers. So it's going to be 719 times 36.8 mils is equal to 802 millimeters times some unknown volume, right? Now I can simply solve this for V2 and get my answer of 33.0 mils. Again, 3 sig digs because everything else had 3 sig digs. Question 4 here, I'm going to not quite solve the whole thing. I'm just going to point out one little quirk about it. It's got 2.9 liters at 91.2 kilopascals. So that's my P1 and my V1, right? This is a volume, this is a pressure. And then it says determine the volume. So my V2 is my unknown at standard pressure. So this is where I'm like, wait, what's standard pressure? So if I go back to page 4, actually all of these values in the middle are your standard pressures, 1 atmosphere and everything else. Now, I don't want to have to do a conversion on this sheet if I can avoid it. So what I'm going to do is I'm going to look up the standard pressure in kilopascals, which are the units that this problem is in. So kilopascals is 101.325. So now I know my P2. And then I'll continue solving that one like I did the previous one. One last one I want to point out is number 5 here. In number 5, you know, it's kind of more of the same. The volume of chlorine gas is 3.16 mils at a pressure of 698 torr. That's equal to some pressure times my new volume, 2.75 mil. Plug those in, solve for the unknown, and you'll get 802 torr. Just a quick logic check on these, right? If the volume has gone down, that means the pressure must have gone up, right? That inverse relationship. So I should be expecting things like that. Anyway, that's page 7. Let me know if you have any questions.